Good morning, dear students. Once again, good morning to you all. I think we did up to this slide, right? This was the last slide we did.
Yes.
Okay. Now, the catalyst, I told you about the catalyst last class. Catalyst is something, what is catalyst doing? What is the catalyst doing? Catalyst is increasing the rate of the reaction. How is it increasing the rate of reaction? By decreasing the energy of activation or activation energy. Okay. Now, there are two types of catalyst. Can you see what is written here? One is called heterogeneous catalyst. The other one is called homogeneous catalyst. Heterogeneous catalyst means if the catalyst and the reactants are in different phases, it's called heterogeneous. See, look here. This is the catalyst platinum. What is the state here? Solid. And here reactant N2O, it is a gas. So solid and gas will not be in the same phase. So this is an example for heterogeneous catalyst. Did you understand? Did you understand?
Yes, doctor.
Okay,
Yes,
so
doctor.
now next.
Yes, doctor.
Syed, you joined just now?
No, I'm there.
Okay. Homogeneous catalyst. Homogeneous catalyst is, now, if the catalyst and the reactants are in the same phase, see, look here. What's the catalyst here? NO. What is the physical state? It's a gas. So this also gas. Okay. All gases will exist as one phase. So as a result, this is called homogeneous catalyst. Did you understand?
Yes.
Yes.
You don't have to
Doctor,
memorize
can you
this.
repeat?
My dear, wait, I'll tell you. You don't have to memorize these equations, okay? You just need to know the meaning. That's it, okay? This is not to memorize. My dear, look here. This is here the catalyst. This is the catalyst. The physical state of the catalyst is solid. This one is gas. So here solid, this one is gas. They are in two different phases. Whereas here this gas, camel gases, all of them in the same phase. So we call it as homogeneous. In this case, different phases, so it's called heterogeneous. Now, okay?
Yes.
Okay, so now in this question, this is a reaction. This reaction you split into two steps, okay? Okay, so these are the reactants, these are the products. In between something else is there, okay? So according to this question, you need to identify the reactant, product, catalyst, and the activated complex. Do you remember the activated complex I told you before? Do you remember that? See, reactants, okay, products, and you get an activated complex, right? Intermediate. Sure?
Yes, doctor.
Okay. So now, okay, tell me what are the reactants and products? Of course, you know, right? Yes, reactants here.
O2 plus I minus.
O2 plus reactant.
H2O2 and I minus.
H2O2.
Yeah, okay, so the reactant is H2O2. Okay, then product.
H2O, O2.
Okay, and then catalyst. Come on.
IO.
Okay, and intermediate. What's the intermediate? Come on, tell. You are sleeping? Are you sleeping, dears? What? Tell.
I
What
don't know.
Yes. What is a catalyst, please? Tell me what's the meaning of catalyst. Catalyst is a substance. Come on.
That
Tell.
increases
Increase.
the reaction
Increases the rate of the reaction and how?
by lowering
by
the
decreasing the activation
By
activating complex.
decreasing the activation energy. Okay, fine. So that means along with the reactants, you add catalyst. Along with the products, you get a catalyst back. Correct?
yes, doctor.
Now look here. This reaction A plus B giving. Can you see this one? A plus B. Okay, I will. Okay. So here the catalyst is the A plus B are the react. A and B are the reactants. C and D are the products. So E is the catalyst. That means E react with the reactant. Along with the product, you get it back. So that means you are adding catalyst with the reactants. Understand?
Yes.
Okay,
Yes.
so now come to this one. Yes, tell me, what are the reactants and products? You know. Reactants, reactant is H2O2. You said correctly. Product also you said H2O and O2. Now tell me, catalyst is, so we have two things you are getting confused with I minus or IO3. Catalyst is the one which you add with the reactants, and with the products you get the catalyst back, correct? So
Yes.
here we are adding and here you are getting. So this is one. Other one is during the reaction it is formed. See? During the reaction, this intermediate is formed, and this intermediate will be finally converted to product. So, what is the catalyst here? Tell me. Catalyst is I minus, because with the reactants you are adding, whereas intermediate is formed during the reaction. So, the intermediate is IO minus. Okay? Understand?
Yes.
Yes.
No.
See here, look here. Look here. The catalyst we add with the reactants, whereas intermediate is this one. This is the intermediate. Understood?
Okay.
This is an activated complex. So are you adding intermediate with the reactants? See this with the reactant, is there are you adding this one, the intermediate? No, during the reaction it is formed. So that means intermediate is the one which is not present with the reactant. Okay, so in this particular question here we are adding I minus. So when you add I minus to the reactant, it is the catalyst. The other one, during the reaction, it is formed. It's coming in the product side in the first case. Okay?
Okay.
Okay, so now reaction rate and temperature. This is the last part of the thing. Listen, as temperature increases, look, did we do this last lecture? No, right? We did this one. Do you remember? K is equal to this one, right? If you remove P and Z, you can see that K is equal to AE raised to minus EA by RT. Okay. Now, if T is high, okay, if the value of T is high, this factor will be high or low?
No.
Low? Low?
High, high.
High?
High.
Oh, you are keep on changing high or low?
High.
Doctor, can you repeat the question?
See dear, if T is high, this much is high or low, the circled one.
it will be low
Why?
because we are dividing by T.
Okay, suppose if EA is high, this factor will be high or low? Hmm?
It will be high because it's minus.
Yes, it's very good. So if T is high, this factor is high. Why? Because of the minus sign. It's in the denominator, but at the same time, it's minus. If this factor is high, what about K? K will be? K will be?
High.
Also high.
Now, all of you know rate of the reaction is equal to K times concentration of the reactant. It can be any reactant to the power M. So, if K is high, rate of the reaction, come on,
Is high.
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 So, what is the conclusion? What's the conclusion?
If T is high,
It's
then
directly proportional to
Yes,
temperature.
yes. So all this you need to know. It's so easy. You don't have to memorize anything. Okay, look, I will explain now. I will read that sentence first of all. As temperature increases, rate of the reaction increases. I hope you understood the meaning. So if T is high, rate of the reaction is high. Second sentence. This is because with increase in temperature, so when you increase the temperature, if the T is high, fraction of molecules whose energy greater than or equal to activation energy increases. Okay, listen. This much is called the fraction of molecules whose energy less than or equal to activation energy. You understand the meaning? These many moles, suppose for the in the hand, for getting A grade is 90 marks. Okay, now this one is a fraction of students whose marks is greater than or equal to 90. Understand? Suppose 10 students are having. Yes. No, just imagine 15. All my students are very good. Okay. Suppose 15 students. How much is the mark for getting 90? Sorry, how much is the mark for getting A grade?
90.
90. Suppose this means the number of students whose marks is greater than or equal to 90. It can be 90 or it can be 91, 92 up to 100. Okay, so that number is the, so how many students will get A grade? Hello, what did I tell? I told you number of students, 15 students are having marks greater than or equal to 90. So how many students will get A grade?
15.
15.
All of
So
them.
same way, this is the number of molecules whose energy is greater than or equal to activation energy. So,
Okay, yes.
okay, you understood? This represents the molecule. This is the number of molecules, not the energy. Number of molecules whose energy is greater than or equal to activation energy. Suppose if the activation energy is 100 or 90, the number of molecules whose energy greater than or equal to 90. If it is 90, you get A grade. If it is more than 90, also you get A grade. Is it clear now?
Yes, doctor.
So if T is high, this much is high. What is this one? The fraction of molecules whose energy greater than or equal to activation energy increases. That means this will increase. Activation energy is independent of temperature. Activation energy does not, don't read it as activation energy increases. No, activation energy is constant. It will not change with temperature. What is the one changing? The number of molecules is changing. Understand?
Yes.
Okay, number of molecules increases. This one is the one increasing, not the energy. Okay, and the fraction of molecules increases. Okay. Okay, so that means if T is high, this much factor is high, so K is high. If K is high, rate of the reaction is high. Is it clear for you? Did you understand?
Yes, yes.
Now, you can derive a relationship. Another very important thing is rate constant K does not depend on the concentration of the reactant, but it's a constant. Rate constant is a constant for a reaction at a temperature. When you change the temperature, K value will change. Is it clear for you? K depends on temperature. So just imagine at a temperature T1, rate constant is K1. At a temperature T2, rate constant is K2. So you can derive a relationship ln K2 over K1 is equal to EA over R 1 over T1 minus 1 over T2. I will come back to this relationship. Okay. Before that, I will tell. See, I have the graph. Come on, tell me. Yesterday you had lab, right?
Yes.
So did they explain all this?
Yes, we saw this graph.
Yeah, and did you understand yesterday?
Some of it.
You didn't understand yesterday. It was good. No, the practical part. The finding order of the reaction M, N, P, and rate constant K, and all that.
Clear.
Okay, yes, okay. So now look here. So I will explain, don't worry. This part I didn't explain in the theory, right? That time. Okay, so K is equal to A e raised to minus EA over RT. To remove this E, the small letter E exponential, you can take ln. So what do you get? Tell me. Ln of K is equal to, tell me.
Ln A.
Ln of A plus ln of exponential minus EA over RT. You know this. Ln and E are reciprocal, so it get cancelled. So what do you get? Ln K is equal to ln A minus EA by RT. Is it okay? Is it okay? Okay. E is the frequency. I forgot to tell you, this is called Arrhenius equation. Sorry, my dear. This equation is called Arrhenius equation. And here A is the frequency, total number of collisions per second frequency. Okay, it's a constant. So now here, I told you EA does not vary with temperature. R is a constant. E is a constant. But if you change T, something else will change. Which one will change?
K.
K. So we have two variables. You know the meaning of variable, right? Two variables. One is K, the other one is T. So you can draw a graph. Now, yesterday's experiment you studied, no? One reaction mixture was done at room temperature, then at 0 degrees Celsius, then at 30 degrees Celsius. You remember the experiment?
Yes, definitely.
So at 0 degree, you get one K value. At room temperature, you get another K value. And then in the water bath, it was, I don't know which temperature your doctor gave. It's 30. Usually we take 30 degree. At 30 degree, you get K. So you have 3 K values and we have 3 T values. Sir?
Yes.
So you can plot a graph. This is like equation of straight line. You know the equation of straight line. What is it? Y is equal to
MX plus K.
mx plus c. So see here, c is the constant, m is and x is here. So what is there on the x-axis? ln k. So easy, right? No?
Right.
On the y-axis, doctor.
Y-axis, what is there? Come on, tell me what is there on the y-axis.
Ln k.
Sorry, what is there on the x-axis?
1/t.
1/t. It means this is 1 is there, no 1/t. Is it clear? So that means you can plot ln k 1/t. See, this k is capital letter K. Kelvin capital letter, rate constant small letter. So easy. So now C, the intercept. What's the intercept? What's the value of C? Come on, tell me. What is the value of intercept? ln A. See, intercept is ln A. Now, what is the slope, my dear students? What's the slope? What's the slope?
Minus A over R.
Yes, the slope is. This is the slope. Okay, slope is minus EA over R. See, minus E over R. Now, the value of R. What's the value of R?
0.081.
My dear. EA. What is EA?
Energy.
Energy. What's the unit of energy?
Joule.
Joule.
Joule. So what is the unit of R?
Also Joule.
Should be
So it will
8.314.
be 8.314 Joule Kelvin inverse mole inverse. Is it okay? Did you understand?
Yes.
Yes. Okay. This is what. So now experimentally, if you did this in the lab, so it's easy for you. Experimentally, you can find the value of slope. You know the value of R, so you can find the value of energy of activation. Is it okay? Is it okay?
Yes.
This is okay. Y-intercept is not this one. This graph, it is showing wrong thing. This is the y-intercept, okay? Intercept ln A. Okay, no. This is the same thing. Oh, I did forget to give a question on it. Okay, so I will write a question. I forgot to type a question. I will write a question for you. Okay, so what's the question? Slope of the graph ln k versus 1/t is minus 800 Kelvin. Find the activation energy. So what is the slope? Tell me. Slope is equal to
Minus EA over R.
minus EA over R. Okay, so the slope is minus 800 Kelvin minus EA. What's the value of R?
8.314.
8.314 Joule Kelvin inverse mole inverse. Correct? Correct? So
Yes.
now EA negative sign get cancelled. So 800 Kelvin times 8.314 Joule Kelvin inverse mole inverse. So Kelvin inverse can
Cancel.
get cancelled. You will get joule per mole. Suppose if the answer is joule per mole, how do you convert it into kilojoule? Please, can you tell me the answer for this, please?
Divide by 1,000.
Yeah, can you please tell this answer, somebody? Because in the test you made mistake.
6,651.
6,651 point something or no? Okay, joule. So this is how much kilojoule? This is how much kilojoule?
6.651.
Yes, 6.651 kilojoule per joule. Listen, in Arabic, I think comma and point are the same. But here, comma and point are different. Don't put comma, okay? Yeah, okay. Then next. Look. This relationship, this one is derived from this formula. Ln K is equal to ln A minus EA over, come on, what is it? RT1, this formula, right? RT. So if the temperature is T1, the rate constant will be K1. If the temperature is T2, the rate constant will be T2. See, look, ln K2 is equal to ln A minus EA by RT2. Okay, so this is the one. So if you solve these two, you will get this formula. What's the formula? Ln of K2. This is small letter K. Okay, K2 over K1, EA over R, 1 over T1 minus 1 over T2. Okay, here important thing is, see, when the suppose if the temperature is low temperature, you can take it as T1. Corresponding rate constant will be K1. When temperature is low, rate constant will be low. When the temperature is high, rate constant will be high. So now, if the temperature is high temperature, so it's T2, rate constant is K2. So don't mix up. Okay, lower temperature, let's take it as T1 to make the calculation easier. Okay, so you can switch also, no problem. But then when temperature is T1, rate constant K1, don't switch that. When temperature T2, rate constant K2. And EA, very important thing, EA must be in, what's the unit of EA?
Joule.
Joule per mole.
Joule. Rashid, okay, it is joule, okay? So if it is given as kilojoule, you must convert kilojoule to joule. What is the reason? Because the value of R is 8.314 joule Kelvin inverse mole inverse. So it's very important. If energy of activation is given, mostly it will be given in kilojoule. So you must convert kilojoule to joule. Okay?
Okay, doctor.
Okay. Now, there's a question. Can you see? For a reaction so and so, the rate constant is so and so at 500 degrees Celsius and so and so at 600 degrees Celsius. Find activation energy. Okay, so first of all, T1, which one you will take as T1?
500 Celsius.
I forgot to tell another very important thing. T1 and T2 must be in Kelvin. Okay. Yeah. Okay. So now T1. Tell me what is T1. Tell please.
500 plus 273.15.
Yes, 273.15. So it will be 773.15 Kelvin. T2. What is T2? 600 plus 273.15 is equal to how much?
873.
873.15 Kelvin. Okay, so now here, K1. Rate constant. This K is capital letter K. Rate constant K is small letter. Okay. When I write on the board, it will never come properly. So K1. Tell me K1. My dear students, tell me K1. Yes.
0.0.
Okay. I am not writing unit. Okay. K2. 20.
It is 20.
Okay. Now, what's the formula? ln of K2 over K1. Both of them are small letters. EA over R 1 over T1 minus 1 over T2. Yes. Come on, help me.
Okay, it is ln 20 over
ln of K2 is what? 20 over 0.05. Yes. EA over R 8.314 joule Kelvin inverse mole inverse. T1 and T2 1 over T1 is how much? 773.15 minus 873.15. Is it okay? Okay.
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 So tell me the answer. 20 over 0.05 ln of the left side value, please tell me.
It is 5.99.
5.99. Two people check, okay? EA over. Can you tell me the answer for the rest?
Okay.
Yeah.
It would be EA over 8.314 multiplied by 1.48 multiplied by 10 to the power minus 4. 1.48 multiplied by 10 to the power minus 4.
1.8 10 to the power minus 4, right? Okay. After 1.8 nothing.
It is 1.48.
Oh, okay. Okay, so now EA is in the calculator itself. You just do the next step. Don't remove it, and okay, the next step also should be done in the same way. Okay, so EA will be equal to 5.99 times 8.314 over 1.48, and this answer you can take the reciprocal and find out the answer. Tell me the answer. Yeah. What is the answer you get?
It is a big number, doctor.
Tell, it's okay.
I converted into kilojoule, it would be 336.49.
So that is 336. After that, tell me the numbers, all numbers.
0.492.
Sorry, 492 joule, right?
That's no, kilojoule. I converted into kilojoule.
This much point is there.
Doctor, the 363.492, it is in kilojoule.
Okay, can you just tell me the numbers, all the numbers, before converting it into kilojoules? Can you tell me the numbers, dear?
Okay.
3364.
492. These numbers are correct, what I wrote?
Yes, it is correct.
Yes.
So that much kilojoules. So I can convert it into kilojoule. Or this, let me write it. This is okay, 336.492 kilojoule. So if it is scientific notation, it will be 3.364 10 to the power, come on, 2 kilojoule, right? Right?
Yes.
You need to know how to write scientific notation. Scientific notation only one digit. Don't write 33.6. Okay, so now next one. Yes, come on. Help me.
Okay, we have EA.
EA Yes, 180 kilojoule per mole. So the most important thing is you must convert kilojoule to
joules.
joules. Yes. Okay, this is very important. Now T1. What is T1?
27 plus 273.15.
Okay, so it is 300.15 Kelvin and K1 is given 0.0175. Now T2 value is how much? 127 degrees Celsius
127.
plus 273.15 is equal to 400.15 Kelvin. So now K2, this small K1 and K2 are small letters, okay? K2 we don't know.
Okay.
Okay. You help me please. Tell the calculation.
We write the
Ln
equation.
Ln of K2 over K1 is equal to EA over R 1 over T1 minus 1 over
is 1
T2.
over T2.
Okay, such a long one. Okay.
Yes.
Okay. Now tell. So ln ln of K2 what's the value of K2? We don't know.
We don't
K2
know.
over 0.0175 is equal to EA is 18 times 1000, right? Over R
Yes.
is 8.314. Now 1 over 300.15 minus 1 over 400.15.
400.
What I want you to do is you just tell me the answer for the right hand side. Just right hand side part.
It is 18.026.
Okay, so that is ln of K2 over, this K is coming big letter, it's not big, 0.0175 is equal to how much, Rashid?
18.026.
026. Okay. Now, the next step, what you have to do is to remove ln, take exponential on both sides. When you take exponential on both sides, ln and e get cancelled. So what do you get? K2 over 0.0175 is equal to e raised to 18.025. Okay, understand?
Okay.
Okay, so K2 will be equal to 0.0175 times exponential 18.025. Please tell me the answer.
26, Doctor.
How much?
18.026.
26, yes, yes. Okay.
To be 117 9316.5.
Oh my God, such a very big number, okay? Maybe I gave some wrong number, okay? That's why it will not be okay. Anyway, whatever be the thing. So what is the answer here? 1 point, I can just write 1.17, I can write 18, 10 to the power, or I'll take 4 digits. So there is no problem. Okay. 1.179, 10 to the power
6.
1, 2, 3, 4, 5, 6, 6. Unit, the same unit. What is the unit? Liter more hours. Okay.
Okay.
Okay. Yes. Now I hope everyone understood all the things. Now I just want to tell a few things. I didn't type it. Look. What are the sentences I gave? This is just a review of on what we did. Rate of the reaction is directly proportional to
Temperature.
Temperature. So if you increase the temperature, rate of the reaction will increase. It's directly proportional to the concentration. When you increase the concentration, the keys of the reactant, rate of the reaction will increase. It's directly proportional to catalyst. If you add a catalyst, rate of the reaction will increase. Now about rate constant K, small letter K. K is directly proportional to
Temperature.
temperature. It's directly proportional to catalyst. You know why? When you add catalyst, EA will be low. Correct?
Yes.
Yes.
If
Yes.
EA is low, K will be
High.
high. Okay, so its rate constant is directly proportional to the catalyst. Then K is independent of something. What is it?
The concentration.
Concentration of the reactant. Then catalyst. What is catalyst doing? Catalyst increases the value of rate constant. Catalyst increases the rate of the reaction. Catalyst decreases the activation energy. But catalyst does not increase or decrease the amount of the product. Huh? Do you remember I gave you an example for this? What example I gave you last lecture?
About the ball, doctor.
About the
Ball.
no. A life example in our
High.
life. Yeah.
High,
Sorry.
high jump maybe.
Not high jump. No, the catalyst, the amount of the product related to the amount of the product.
The apple.
Apple means eating. No, my dear. No. I'm just telling, if you add a catalyst, it will not give more product. It will not give less product. It will make it fast. So I gave you an example for this. You are staying in Muharraq. Next semester you are going to UOB. You can go by car. You can go by walking. Distance same in both cases, right? Muharraq to your home to UOB, distance same. But if you use car, what's the advantage?
We will get earlier.
Time is less.
You will go fast. You can reach fast. But the distance is same, right?
Yes. Right.
This is what catalyst is doing. Catalyst will not do anything with the product. You won't get more or you won't get less, but it will make it fast. Is it okay?
Yes.
Now, this question we asked in the previous exam. Look, I finished the lesson. Okay, my dear, I'll just want to give a few questions from the previous exams. For the overall chemical reaction given below. So this one, okay, the reaction is given here. Reaction is third order. Overall order of the reaction is 3. The order of the reaction is second order. Rate law is so and so. Or rate law is so and so. And another one is rate law cannot be determined from the above information. What is the answer?
E.
Why?
Because we don't have much information about the constants or the order of the reaction to determine what is the overall order.
Why don't you take it this 2 and this 1?
These are the moles, not the order of the reaction. We can't determine.
Yes. So the thing is, in order to do this question, you need to get the data. This coefficient will never be, or not never be, coefficient need not be equal to the power. You cannot write the power like this. Okay, you have to do the experiment. These values, the order of the reaction is experimental. You have to do the experiment and find the answer. Otherwise, you can't get it. Now, next question. A reaction is experimentally found to follow this one. Rate constant is so and so. Starting with so and so, how many seconds will it take for this one? So, how will you solve it? Come on, we finished this one, no? Which formula you will use? What's the order of the reaction here?
It's the second order.
Second order. See, From this rate law, you can get second order, or from the unit of this one also you can get it as second order. Okay. So what's the formula?
Yes.
Order is 2. Okay. Yes. Tell me. 1 over
A
minus
1 over
1
A
over is equal to KT. Yeah. Tell me the substitution.
Yes.
Tell me. 1 over
0.150.
Yes, this is the final Turkish minus 1 over A naught. What is A naught?
1.55.
Okay. Is equal to
0.355.
Okay.
T.
T. Is this correct?
Yes.
See, this is the way you lose marks, my dear. Of course, you will get the answer of T in what unit? Minutes. See, this is the place you go wrong, my dear, in the imtihan. Here it is molar raised to -1, minute to the power -1. So you get the time in minutes. Look at these values. And here in the question, what is asked?
Seconds.
And
Seconds. After finding the minutes, how do you suppose you get X minutes? So how do you convert it into seconds? X times 60. Okay, so this is the way you lose marks. Okay. Now calculate the activation energy. Oh, I forgot to take the data. There was a data for this one. Okay, let me see if I have it or not. Yes. Can you see these values?
Yes.
Yes, these are the things given. Okay. I'll write here. There is no place. So just now we did. So when you see this table, don't get confused. When temperature is 2 degree, K is so and so. When temperature is 27 degree, K is so and so. So you have to find the activation energy in which unit?
Kilojoules.
Kilojoule. So you know which formula was. So you have to convert. You know how to do it, right?
Yes.
Yes.
T1 is 2 plus 273.15. T2 is 27 plus 273.15. K1 is 3.12 10 to the power 3. K2 is 27 into 10 to the power 3. Okay, so you will get the ln K2 over K1 is equal to EA over R 1 over T1 minus 1 over T2. Okay, so you get the value of EA in joule. So how do you convert it? Say you get X joules. So how do you convert joule to kilojoule? X
10 to the power minus 3.
divided by 1000 or multiply by
10 to the power -3.
Yes, X 10 to the power minus 3 kilojoule or divide by 1000. So be careful when you solve the questions. Okay, so you will not lose marks. Okay, dears, I finished the lesson. I hope you understand it.
Yes,
Okay.
thank you, Doctor.
Yeah, okay. Let me download the attendance sheet one more time. How many students are here? Only 64. Usually 70 students are there. I have 93 students.